We're going to go from the standard form to the vertex form of a quadratic. So I've got a whole bunch of letters here, but essentially here's your standard form. Okay, you have your A, your B, and your C. You have to make sure you can pick out those two coefficients and this constant value. Okay, and the exact same equation can be represented in a vertex form. And the benefit of a vertex form is usually much easier to graph because they give you the H and the K are the X value of the vertex and the Y value of the vertex. So in other words, they've given you the coordinates of the vertex. Okay, and then from there you kind of just work on compression and stretching. Okay, so that's the benefit of vertex form. And to go from the standard to vertex form is usually completing the square. Okay, that's the process they use to do it. Another thing you can do is you can use these two formulas. Okay, so what we'll do is I'll complete the square, and then I'm going to show you how you can use these same two formulas to go right from here to here without actually having to go through that entire process. Okay, so now this formula they've given us, they've actually set it equal to 0. So we're going to have to keep it set equal to 0 the entire time as we go through it. When you complete the square, the first step is usually to divide the first two. And have they taught you to divide all three or just the first two?
By what?
By the A value. So whatever the A value is.
Oh,
so in this case,
the first one, because then you bracket off the.
Yeah, exactly. So it's best. You can do it by doing all three, but it's kind of redundant. So we're just going to divide the very first two by the A value, and it happens to be 1 in this case, so it's not going to make any real changes. Okay, but our 1 is common factored out. And then we're left with the exact same stuff we had before. In many cases, that won't be. These things will change if the A value is different. Right? And then this would be considered like a new B value. And you do like a side envelope here calculation. They say B squared divided by 2. And that'll tell you what you're going to take our new B value. And we plug it in, divided by 2. So that gives us 2. So we're going to have 2 squared is 4. Great. So we're going to add and subtract the value of 4 within that bracket. And the reason we can add and subtract within the same bracket, because if you add 4 and subtract 4, it's just like adding the value of 0. It does nothing to anything within that bracket. It doesn't change anything. Okay. So what we want to do is we want to take out the negative value. We want to pull it outside the brackets. But when you do that, you need to multiply it by whatever that A value is. In this case, it's 1, so it's not going to make any changes, right? So we'll be left with x squared plus 4x plus 4. Outside the brackets, we still have our negative 4, and we're just going to add it to 1. Still equal to 0. Now what this is called a perfect square trinomial. Okay, so there's a special way you can kind of go about factoring this, but all you really need to know is the really fast way to do that is to square root the first and the last term, and that will give us the first and second term within our brackets here. So we're going to have the first term.
It always is.
Yeah, it's going to be half the middle number. That's right, when we square root it. So we have square root of x x squared is just x. Square root of 4 is just 2. And we use whatever sign is in the middle. So if this was addition, you bring down the addition sign. If it was subtraction, you bring down subtraction. Negative 4 and 3 will be negative 3 is equal to 0. So we're now in our vertex form. This one was a little bit easier to do because we didn't have any fractions involved. The A value was only 1. We didn't have to do any extra calculations with that. Another way we could have gone about doing that is using these two formulas. So I'm going to do that again, the exact same equation, and show you how to build it. So the equation states that the x value of the vertex is equal to negative b over 2a. I'm going to rewrite our equation here. What was it? X squared plus 4x plus 1. So x squared plus 4x plus 1 equals 0. And our y value of the vertex is c minus b squared divided by 4a. Okay, so as long as we can pick out each of these values, let's move this down so it's a little easier to work with. We know that our a value is 1, our b value is 4, and our c value is also 1. We can just plug things into the formulas and they're going to give us exact values. So let's do the x value first. So the x value of the vertex, it's a positive 4, but because it's going to be negative b, we'll have negative 4 divided by 2 times, and the a value is just 1. So it's like negative 4 divided by 2, which gives us an x value of negative 2. Okay, so that's going to be important to us when we go to rebuild our vertex form. And the y, our c value is 1. So the y value of the vertex is 1. Subtract. Our b value is still 4. We're going to have to square that 4 before we divide it by 4. And a, once again, is only 1, so it's not really going to change anything down there. So we have 1 subtract. 4 squared will be 16. And on bottom, 4 times 1 will be just 4. We'll divide this fraction. So 16 divided by 4 will give us 4. 1 subtract 4 will give us negative 3. So our y value of the vertex is negative 3. So I'm going to write the vertex form out so that we can kind of figure out where we put this information. So if you remember, it was written as f at x is equal to a x minus h squared plus k. So the x value of the vertex is actually your h value also. Okay. So in other words, we're going to replace this h value with negative 2. Okay. And we're going to replace this k value with negative 3. So we go to write it in. We still don't know our a yet. Of x subtract negative 2. So we're subtracting negative 2. And then we just plug in negative 3 here because this is a positive value. When you have two negatives beside each other, you can simplify by just writing it as a positive. So we have ax plus 2 squared minus 3. And what's really good about a is the a value, all the way to the top. The a value is the same, whether in standard form, or you're in vertex form, or you're in factored form. So because our a value here was 1, that means our a value all the way down here is just the value of 1. So I did a lot of extra steps. That could have been built much, much quicker. We're left with x plus 2 squared minus 3, which is x plus 2 squared minus 3, the exact same value we had. So whether you complete the square or use the formulas, you can still get to the vertex form. It doesn't matter which method you use when doing it. For this part, we know our vertex, our x value of the vertex, and our y value of the vertex are negative 2 and negative 3. So we know where the vertex is, but we need to find our two x-intercepts, let's say. Okay? So in order to do that, you need to set the equation equal to 0. And luckily, they had already done that for us. Okay? Say there was a value on the other side, you would have had to bring it over. You need to set it equal to 0.
Like y? What if there's y there?
If there's a y there, you replace the letter y. So say it was y is equal to x plus 2 squared minus 3. Replace y with 0. Okay?
Is it 0 over top of 0?
Yeah, and the reason being is because if you're on your graph here, when the y values are 0, so that's what we're doing. We're finding out when y is 0. That's when you're crossing the x-intercept. So anything along there must be a 0. Must be an x value. Okay. So once you do that, the whole point is to try to isolate for x. And sometimes they'll tell you when isolating for variables to use something called like reverse bedmass or something like that. But simply, we just got to move everything. We want to get the x by itself. That's going to be the entire goal here. Okay. So the very first step, we'll take this negative 3 and move it to the other side. So when we do that, it would become positive 3. You guys are okay with that idea? Yeah? Okay. So we get 3 on this side. The next step after that will be the power of 2. The opposite of the power of 2 will be the square root. Okay. So now we have root 3. And in the question they asked us, and what we'll do is we're going to find the exact value, and we'll find the
approximate?
Yes, that's what I'm looking for, the approximate value. Yeah. So when we do this, the root and the power are going to cancel out. You have a bracket of x plus 2, but we don't really need the bracket anymore. There's nothing for it to contain, so we're left with x plus 2 is equal to, and we're just going to leave this as root 3, because we know root 3 is going to be some type of decimal that goes on in a rational number. So the next step,
move the 2 over.
That's it. We move the 2 over, okay, and it becomes a negative 2. So you have x is equal to the root of 3 minus 2.
Could you
now,
put negative 2 root 3?
You could rearrange the order negative 2 plus root 3. That would work fine. Now, from here, that looks like one x-intercept, okay? And if I try to plot this, negative 2 and the x values is here, negative 3 is here, our a value was a 1, I should have 2 x-intercepts. And this looks like it's only one value here. But the reason being is because when you square root something, there's technically always 2 answers to it. There's a positive value and a negative value. Okay, so there's actually 2 answers here. Our answers are positive root 3 minus 2 and negative root 3 minus 2, whatever those two are. Okay, so those are our x-intercepts, our x values. So those are the exact values. We can't really do anything to break down 3. It doesn't have any roots in it. For approximate values, we can take out our calculator here. And the square root of 3, okay, is equal to that. And we subtract 2 from it. Oh, sorry, I didn't put the value in. That doesn't make sense. There we go. And here's our first approximate value. Okay, so negative 0.27 we'd round it to. So this would be negative 0.27, so 0.27. And our other value, we had negative root 3. So that gives us a negative this out. And then when we subtract 2 from it, it'll become negative 3.73. So approximately negative 3.73. So these are our two x-intercepts. And that kind of makes sense from where I graphed it. This one was pretty close to the y-intercept. That's probably our 0.27. And this is probably our negative 7.37.